Okay, good morning. The topic that I'm going to discuss today is the standard units and areas under the standard normal distribution. So first, let us have a review of what is a normal curve. The graph of the normal distribution depends on two factors, the mean and the standard deviation. The mean of the distribution determines the location of the center of the graph, and the standard deviation determines the height and the width of the graph. So here, again, our normal curve, our mean is at the center, and the spread of our data, okay, this is our number of standard deviations. For the standard normal distribution of a random variable, it is a normal distribution with mean mu is equal to 0 and sigma is equal to 1. So the letter z is used to denote the standard normal variable. The specific value of z of a random variable z is called the z-score. So the z-value or z-score gives the number of standard deviations between the original measurement x and the mean mu of the x distribution. This is the formula that we are going to use. We have there z is equal to x minus mu over sigma. So in our table, it shows us the x values and the corresponding z value. For x is equal to mu, our z is equal to 0. If x is greater than the mean, then z is greater than 0. If x is less than the mean, then z is less than 0. Given x distribution with mean mu and standard deviation of sigma, the row score x corresponding to a z-score is x is equal to z sigma plus mean. For our example problem, a pizza parlor franchise specifies that the average amount of cheese on a large pizza should be 8 ounces and standard deviation is only 0.5 ounce. An inspector picks out a large pizza at random in one of the pizza parlors and finds that it's made with 6.9 ounces of cheese. Assume that the amount of cheese on a pizza follows a normal distribution. If the amount of cheese is more than 3 standard deviations below the mean or -3, the pizza parlor will be in danger of losing its franchise. Is the pizza parlor in danger of losing its franchise? So let us compute for our z-score. So we are given the mean of 8. Our standard deviation of 0.5. Our row score of 6.9. Okay, so what is our z? Z is equal to x minus mu over sigma. That is equal to, we have 6.9 minus 8 divided by 0.5. It gives us -2.2. Okay? So, what does it mean? It means that the pizza parlor is not in danger of losing its franchise. Another problem. Marula's z-score on a college entrance exam is 1.3. If row score have a mean of 480 and standard deviation of 70 points, what is her row score? Okay, so we are given z, that is 1.3, our mu of 480, our standard deviation of 70. So we are looking for the row score, x. See, x is equal to z sigma plus mu, which is equal to 1.3 times 70 plus 480. And x is equal to 571. So Marula's z-score is, Marula's row score is 571. Okay, so for the areas under the standard normal curve, okay, it is better if, or it will be of great help if we are going to utilize the stat mode in our calculator. To do that, okay, first, we have to press mode 3, 1, and then it's already in our stat mode. And then on. And then shift 1, then choose distribution. Okay? So in other calculator, it may be in number 7 or number 5. Okay? So distribution. So there will be 4 choices. We have number 1 is P, okay? Number 2 is Q, number 3 is R, and number 4 is T. Okay? So, our concern is where P, Q, and R. Okay? So, when we say P, it is this area. Okay? So, if it's Q, the area, this is its area, and R is this area. Okay, so example. Find the area under the standard normal curve between z is equal to 0 and z is equal to 1. Okay? So, I'm going to draw the curve. Okay, you have there z is 0, so that means x is equal to the mean, that is 0, it's here, and then to z is equal to 1, so it's positive, so it's where? It's located at the right of the curve. So we have here 1. Okay? So, I'm looking for this area. So simply choose, okay, number 2 or Q in your calculator. So we have there Q of 1, we have 0.34134. Okay? So, for the second one, we have find the area under the standard normal curve between z is equal to 0 and z is equal to 2.53. Okay, again, let us draw the normal curve. You have here, z is 0 to 2.53. So, it's where? It's positive, so it's located at the right. So, that's 2.53. So, our concern is this area. So, that is again, Q of 2.53. So we have there 0.4943. Okay? Then, for the third one, find the area under the standard normal curve between z is equal to negative 2.34 to 0. Okay? So we have here our normal curve. Okay? So, we have here 0. Negative 2.34 is located where? Since it's negative, it's located at the left. So we have here our negative 2.34. Okay. So, this is the area that we need to find. So again, it's Q. Okay. So, we have there Q of 2.34. Okay. We have 0.49036. Okay? Okay, next. Find the area under the standard normal curve between z is equal to negative 3 and 2.65. Okay? So, again, let us draw. Okay? We have here our negative 3 and our positive 2.65. Okay? So, we need to find this area. So, that is, of course, we have Q of 2.65 plus the Q of 3. Okay? So, we have 2.65 is 0.49598. Then, for the Q of 3, we have there 0.49036. 865. Okay, so let's get the sum. Okay, so we have there 0.99463. Okay, so next, find the area under the standard normal curve to the left of negative 0.94. Okay, so let us draw our normal curve. We have there negative 0.94 is located where? Since it's negative, it's at the left. Negative 0.94. So we need to find the area, okay, under the standard normal curve to the left. So it means that we need this area, okay? And this is what? R. Okay, that's R of 0.94. So that gives us, okay, 0.17361. Okay? What about the next one? Find the probability of P of Z is greater than or equal to 1.15. So let us draw the curve. We have there 1.15 is positive, so it's located at the right. That is 1.15. And this is our area of concern. So this one is again R of 1.15. We have there 0.12507. Okay? Okay. So let X have a normal distribution with mu of 10 and sigma of 2. Find the probability that an X value selected at random from this distribution is between 11 and 14. So in symbols, find P of 11 is less than or equal to X is less than or equal to 14. So since we are given our row score, then we need to convert it first to Z-score and then find the area. Okay, so for this example, we have there the mean of 10, standard deviation of 2. Okay, we have row scores of 11 and 14. Okay, so we have here 11 minus 10 divided by 2 is less than or equal to Z is less than or equal to, we have 14 minus 10 divided by 2. So this one, it gives us 0.5 is less than or equal to Z is less than or equal to, we have 2. Okay, so let us draw the normal curve. We have there, okay, where is 0.5 and where is 2? So here, we have here our 0.5 and our 2. Okay, so we need to find this area. So that would be, first, find the Q of 2, then subtract the Q of 0.5. Okay, to find this area. So what is the Q of 2? We have 0.47725 minus Q of 0.5. That is 0.19146. Okay? Gives us we have 0.28579. Okay? Another example. The Sunshine Radio cassette deck life was normally distributed with a mean of 2.3 years and standard deviation of 0.4. We wanted to know the probability that the cassette deck will break down during the guarantee period of 2 years. Okay? So, again, what is our mean? We have 2.3. Then, our standard deviation is 0.4. Okay, our X is 2. So let's compute for the z. That is, z is 2 minus 2.3 divided by 0.4. So that gives us okay. We have negative 0.75. Okay? So we have here our normal curve. Okay? Negative 0.75 is located at the left. Okay? So, we wanted to know the probability that the cassette deck will break down during the guarantee period of 2 years. Okay? So, it will not break down until this point. So, that is R of 0.75. We have that is 0.22663. Okay, another example. Porphyrin is a pigment in blood protoplasm and other body fluids that is significant in body energy and storage. Let X be a random variable that represents the number of milligrams of porphyrin per deciliter of blood. So in healthy adults, X is approximately normally distributed with mean of 38 and standard deviation of 12. Okay, so what is the probability that X is less than 60? Okay, again, our mean is 38 and standard deviation is 12. Okay, you have their mean of 38, standard deviation of 12. So for the first one, X is less than 60. So we have Z is equal to 60 minus 38 divided by 12. That gives us 1.83. Okay? So, now our normal curve, we have there 1.83 is here. Then we were asked, okay, less than 60. So it means it is here. Okay? So we have P, that would be P of 1.83. This one, 1.83. We have there 0.96638. Okay? What about X is greater than 16? So we have there Z is equal to 16 minus 38 over 12. That is negative 1.83. So we have here our normal curve. Our negative 1.83 is here. So greater than this one. So it means it is located where? At the right. So that is also P of 1.83. And that is 0.96638. Okay? What about X is between 16 and 60? So that would be 16 minus 38 over 12 is less than or equal to Z is less than or equal to, we have 60 minus 38 over 12. And that is 1.83. Negative 1.83 is less than or equal to Z is less than or equal to 1.83. So we have there our normal curve. We have here negative 1.83. This is positive 1.83. So we need this one. So that is Q of 1.83 times 2. We have there Q of 1.83 can be multiplied by 2. So we have there 0.9327.6. Okay? What about if X is more than 60? Okay? So we have there, again, Z is equal to 60 minus 38 over 12. That is 1.83. More than 60, that will be, okay, we have here our 1.83. that is more than 60. So this is R of 1.83. We have there 0.033625. Okay? Okay. Another problem. In the town of Rockwood, a survey found that the number of hours grade school children watch TV per week is normally distributed with mean of 20 hours, standard deviation of 2 hours. If a child is chosen at random, what is the probability that he or she watches TV less than 14 hours per week? So given our mean is 20, our standard deviation is 2. Okay? So less than 14 hours per week is, we have Z is equal to 14 minus 20 divided by 2. That is -3. So that is less than 14 hours per week. So we have here our normal curve. -3 is here. Then less than that, that is at the left of -3. So that would be R of 3. We have 1.35 times 10 to the -3. What about more than 22 hours per week? So that will be Z is equal to 22 minus 20 divided by 2. We have there 1. Okay? So that would be more than, we have here our standard, our normal curve. This is 1. So we need to find, okay, the area to the right of 1. So that will be R of 1. That is 0.15866. Okay? Then, between 18 and 20, so we have there 18 minus 20 over 2 is less than or equal to Z is less than or equal to 20 minus 20 divided by 2. So this one is -1 is less than or equal to Z is less than or equal to 0. So our area is, okay, we have here 0 and we have here -1. So we need to find this area. So that will be what? Q of 1. That is 0.34134. Okay, another one. A flight for life helicopter service is available for emergencies occurring 15 to 90 miles from the hospital. Other emergencies are serviced by ambulance. A study of the service shows that the response time is normally distributed with a mean of 42 minutes and standard deviation of 8 minutes. So for a random call, what is the probability that the response time will be? Okay, between 30 and 45 minutes. So again, our mean is what? We have 42 and standard deviation of 8. So we have 30 and 45 minutes. So we have here 30 minus 42 over 8 is less than or equal to Z is less than or equal to 45 minus 42 over 8. Okay? So we have there 30 minus 42 divided by 8. That is -1.5 is less than or equal to Z is less than or equal to. We have 45 minus 42 divided by 8. That is 0.375. Okay? So, in our normal curve, we have here our -1.5 and positive 0.375. So we need this area. So that is Q of 1.5 plus Q of 0.375. We have Q of 1.5 is 0.43319 plus Q of 0.375 That is 0.14617. Okay? So let's just add that. 0.43319. We have 0.57936. Okay? So, what about less than 30 minutes? So, we have here our less than 30. That is A is equal to 30 minus 42 over 8. That is negative 1.5. Okay? So, less than 30 minutes. We have here our negative 1.5. So, less than that. So, that is located where? At the left. So, that will be R of 1.5. We have 0.066807. Okay? Then, what about more than 60? So that is A is equal to 60 minus 42 divided by 8 gives us 2.25. Okay? So this is our curve. We have here our 2.25. So more than that. So that will be where? At the right of 2.25. So that will be R. We have there 0.012224. Okay? Another one. An average light bulb manufactured by Acme Corporation lasts 360 with a standard deviation of 50 days. Assuming that a bulb life is normally distributed, what is the probability that an Acme light bulb will last at most 365 days? Okay? So we are given what? Our mean of 300, our standard deviation of 50. Okay? So we have here Z is equal to, we have 365 minus 300 over 50. So that is 1.3. So that is positive. So it's located where? At the right. This is 1.3. So at most is 365 days. So that means this is, or we need to you get the P of 1.3. Okay? You have there 0.9032. Okay? 0.9032. Okay, another one. Suppose scores of an IQ test are normally distributed. If the test has a mean of 100 and standard deviation of 10, what is the probability that a person who takes the test will score between 90 and 110? We have here mu is 100, sigma is 10. Okay? So we need to find the area, okay, between 90 and 110. So we have here 90 minus 100 over 10 is less than or equal to Z is less than or equal to, we have 110 minus 100 over 10. So we have here negative 1 is less than or equal to Z is less than or equal to positive 1. So let us draw our normal curve. Okay? We have here our negative 1. This is our positive 1. Okay? So we need this area. So that would be Q of 1 times 2. Okay? We have 0.34134 times 2. That is, we have 0.68268. Okay. Next is we have the average speed of a car is 65 kilometers per hour. with a standard deviation of 4. Find the probability that the speed is less than 60. We have here mu is 65. Then our sigma is 4. Our x is 60. So if there's z is equal to 60 minus 65 divided by 4. So that gives us negative 1.25. So in our normal curve, okay, so we have here our negative 1.25. So less than that, so it's located where? At the left. So that will be R. Okay, R of 1.25 is 0.10565. Okay. Then we have next is the average score of a statistics test for a class is 85 with a standard deviation of 10. Find the probability of a random score falling between 75 and 95. So our mean is 85. Our sigma is 10. Okay? So here we have 75 minus 85 divided by 10 is less than or equal to z is less than or equal to 95 minus 85 over 10. So this is negative. Again, negative 1 is less than or equal to z is less than or equal to positive 1. Again, our area is this one. Okay, we have there negative 1 and positive 1. Okay, so again, that's Q of 1 times 2. We have there 0.68268. Okay. Next, a radar unit is used to measure speeds of cars on a motorway. The speeds are normally distributed with a mean of 90 kilometers per hour and a standard deviation of 10. What is the probability that a car picked at random is traveling at more than 100 kilometers per hour? So we have there mu of 90, sigma of 10. Our x is 100. So we have there z is equal to 100 minus 90 over 10. So that is z is equal to 1. Okay? So we have here our normal curve. Positive 1 is there. Then we need that is more than 100 kilometers. So it is where? At the right of 1. So that is R of 1. That is 0.15866. Okay? Okay. For a certain type of computers, the length of time between charges of the battery is normally distributed with mean of 50 hours and standard deviation of 15. John owns one of these computers and wants to know the probability that the length of time will be between 50 and 70 hours. Okay? So you have their mu of 50, sigma of 15. Okay? So, we need to find the probability is between 50 and 70 hours. So we have here 50 minus 50 over 15 is less than or equal to z is less than or equal to 70 minus 50 divided by 15. So this is 0 is less than or equal to z is less than or equal to, we have 1.33. Okay? So we have here 0 to 1.33. So we can use Q. Q of 1.33. That is 0.40824. Okay? Next is the normal approximation to the binomial distribution. Okay? So here, If NP is greater than 5 and NQ is greater than 5, then R has a normal distribution, has a binomial distribution that is approximated by a normal distribution. Okay? So we have here the formulas that we are going to use is mu is equal to NP and sigma is equal to the square root of NPQ. We all know that mu is the mean, N is the number of trials, P is the probability of success on a single trial, and sigma is the standard deviation. Then, of course, Q is the probability of failure on a single trial. Okay? So, since this is a binomial distribution, so we need to make a continuity correction. So, how are we going to do that? If you can still remember, in our histogram, we subtract 0.5 from the lower interval or from the lower boundary and add 0.5 to the upper boundary. So that also applies here. Okay? Example. For many years of observation, a biologist knows the probability is only 0.65 that any given Arctic tern will survive the migration from its summer nesting area to its winter feeding grounds. A random sample of 500 Arctic terns were banded at their summer nesting area. Use the normal approximation to the binomial to find the probability that between 310 and 340 of the banded Arctic terns will survive the migration. Okay? So, here, we are given our N is 500. Our P is 0.65. Okay? So, we can compute for our mu. Our mu is NP, that is 500 times 0.65. So, that is 325. Okay? Our sigma is equal to the square root of NPQ. That is equal to square root of 500 times 0.65 times 0.35. Okay? So, this 0.35, this is our Q, that is equal to 1 minus P, which is equal to 1 minus 0.65. Okay? So, our sigma is equal to what? We have 500 times 0.65 times 0.35. Okay? Get the square root of that. That is 10.67. Okay? So, we can now get the z-scores. Okay, we have 310 to 340. So, 310 will be 309.5 minus 325 divided by 10.67 is less than or equal to z is less than or equal to, we have 340.5 minus 325 divided by 10.67. So, that would be, so we have 309.5 minus 325 divided by 10.67. That is negative 1.45 is less or equal to z is less or equal to, we have positive 1.45. Okay? So let us again draw our normal curve. We have here our negative 1.45 and positive 1.45. So we need that area. So that is simply Q of 1.45 times 2. So we have there 0.85294. Okay? Okay, so for our last problem, USA Today reported that 11% of the books sold are of romance genre. So if a local bookstore sells 316 books on a given day, what is the probability that we have 25 and 40 are romances, including 25 and 40, of course. Then in the solution, what is N, what is P, what is Q, and is it a good approximation? Okay, so given that P is 11% and N is 316, our P is 11 and our N is, how many? We have 316. Okay, 316. What is our Q? So our Q, okay, that is equal to We have 1 minus 0.11. That is 0.89. Okay? So is it a good approximation? So let us compute for that. So remember, if n is, here, okay? So if NP and NQ is greater than 5, then it is a good approximation. Okay? We have NP is equal to, we have N is 316 times 0.11, that is equal to 34.76, and that is greater than 5. So it means that it is a good approximation. Let us test NQ. We have 316 times 0.89. So is it greater than 5? We have there 281.24. So it is a good approximation. So what is the probability, that between 25 and 40 are romances? We have there 24.5 minus our mean is 24.5 minus our mean of, this is our mean, that is 34.76 divided by, we do not have our standard deviation, so let us compute for that. Sigma is equal to the square root of NPQ, that is equal to, we have 316 times 0.11 times 0.89. Then get the square root of this. We have 5.56. We have 5.56 is less than or equal to Z is less than or equal to 40 minus 34.76 divided by 5.56. So that is, we have 24.5 minus 34.76 divided by 5.56. We have, in our normal curve, we have here negative 1.84, okay, or 84. Then we have 40 minus 34.76 divided by 5.56. We have 0.94 positive. So that is 0.94. So let us get this area. So that will be Q of 1.84. We have 1.84. That is 0.46712. What is Q of 0.94? We have there 0.32639. So we add, so plus 0.46712. We have there 0.79351. So this is our